Let's look at the solutions of modern maths bytes. A photograph needs to be clicked of the graduating batch. The photo will include the 12 students, the 5 supporting staff, and 3 faculty members. These 20 people need to be arranged in 3 rows. 4 kneeling in front, 7 seated in middle row, and 9 standing in the last row. Okay, so 4 sitting in front, and 7, 1, 2, 3, 4, 5, 6, 7 in the middle row, and 9 in the last row. Okay, we've got this. If those kneeling have to be students, 3 faculty members had to be in the middle of those seated. 7 seated in the middle row, so these 3 are faculty members. And 5 support staff have to be in the middle of those standing. So 2, 1, 2, 1. These spots are for support staff. In how many different ways can the arrangement be done? Now, after having drawn all this, can we see this? The position for faculty is fixed. The position for support staff is fixed, but they can rearrange themselves in 3 factorial and 5 factorial ways. Their order within those spots is not fixed. And the remaining 12 spots that are available for 12 kids. They can rearrange themselves. So that can happen in 12 factorial ways. So you don't need to select anything. You don't need to divide by anything. This is the only expression you need. Answer has to be option B. Next question. In how many ways can the letters of the word nationality be arranged such that vowels and consonants are alternate? Okay. Let's see. This is a vowel. 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 How many letters here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters and 5 of them are vowels. So can you see the order? In order to ensure that they are alternate, it has to be consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. This is the only order that works. This is the only order that works. If this is the only order that works, let's look at all the vowels. How many do I have? 1, 2, 3, 4, 5. 5 of them. They can be rearranged in 5 factorial ways. But because A is repeating and I is repeating, I have to also divide this by 2 factorial. 2 factorial. This takes care of the vowel part of our storyline. Now let us come to consonants. Of course, there are 6 consonants because 5 vowels and total 11 letters. So 6 consonants. But within consonants, do we have any N and N is same. T and T is same. L and Y are different. Okay. So I need 1, 2 factorial here and 1, 2 factorial here also. And this should give me all my possible cases. So 120 by 4 gives me 30. 720 by 4 gives me 180. So it should be 54 followed by 2 zeros. So answer has to be option C. Next, 2 numbers are randomly selected simultaneously from the first 60 natural numbers. What is the probability that neither of the selected numbers is divisible by 4 or 5? Okay. First, let me find out probability that it is divisible by 4 or 5. For that, I will need help of set theory. Multiple of 4 and multiple of 5. We are only considering the first 60 natural numbers. So multiple of 4 and multiple of 5. The intersection is going to be multiple of 20. In the first 60 natural numbers, there are 3 multiples of 20. Now, how many multiples of 4? 15, of which 3 are listed here. So this will be 12. Multiples of 5 are 12, 9 here. We have got all multiples of 4 or multiples of 5 we have identified. Now, next thing is, how many are neither multiples of 4 nor multiples of 5? 36 such numbers. But we are selecting 2 numbers randomly. So our work has to be 36 by 60 into 35 by 59. These 2 numbers. Okay. So cancel 3, cancel 5, cancel 7. We end up with 21 by 59. And at this time, it may seem like, oh my God, we don't have the option 21 by 59. What do we do? At least, hopefully, at this time, you can rule out B and C are definitely not the answer. B and C are definitely not the answer. The answer is somewhere here. Now you have to go back and check whether these options can be simplified to this. If you notice, the numerator and the denominator, if you cancel out 3's here, will turn to 21 by 59. And therefore, the answer is indeed option A. Next question, in how many ways can two and identical objects be distributed among n people such that each person receives at least one object? This is basically a theory question. N plus R minus 1 divide C R minus 1 is for what? When you have no constraint, as in whole number solution sets you're watching. But this entire thing changes. This entire thing changes to N minus 1 CR minus 1 as soon as you're looking for natural number solution sets. These many articles, these many people, basically answer has to be option B. Other way you can potentially think of here is just assign values to N, 2N and N. Assign values to 2N and N. I'm saying let N be equal to 1. So 2N will be equal to 2. 2N will be equal to 2. If 2N is equal to 2, in how many ways can you assign that object? In how many ways can you assign that object to the person? Let's see here, it will turn to how much? 3n minus 1. So 2c0. Oh, this is also 1 because everything is n minus 1. This will not work. Sorry. Let me just change it. If we had n equal to 2, so 2n will be equal to 4. So A plus B is you have to give them 4 items. So you can either give it, and everybody has to receive either 1 3 or 2 2 or 3 1. There are 3 ways. 3 ways. So let's see 3n minus 1, 5c1. No, this is not fine. 2n. So 4c1. No, this is not fine. Here you have 3c1. Yes, this is fine. Here you have 6c1. No, this is not fine. Even still, you would still reach the same answer. The answer doesn't change. Last one. Telsin Limited has 3 projects ABC, and there are a total of 34 employees, each of whom is working on at least one of the 3 projects. The number of people who are working on only AB is 12, only BC is 10, and only AC is 6. The number of people working on A is 20. The number of people working on only one project is same for all the 3 projects. Find the number of people working on all 3 projects. Okay. Let me record the information. I have project A, I have project B, I have project C. Total of 34 employees, each of them. The number of people working on only A and B is 12. So this is 12. Only B and C is 10. So this is 10. And only A and C is 6. The number of people working on A is 20. Okay. This is 20. And the number of people working on only one project is same for all the 3 projects. So if this is X, this is X, this is X. Additionally, can you see this portion in the middle? The number of people working on all the 3 projects. We can now ascertain that out of 20 people of A, 18 are already accounted for. X is here. So this has to be 2 minus X. This has to be 2 minus X. Now, people of A plus these 3 sets, people of A plus these 3 sets should add up to 34 because 34 total employees and everyone is working on at least one. So 20 plus 10 plus 2x is equal to 34, or 2x is equal to 4, or x is equal to 2. If x is equal to 2, this is 2. This region here is 0. This is 2. This is 2. So number of people working on all three projects is option D, 0. There is nobody who's working on all the three projects. That will be all for this episode. Okay, bye people.